Fire. The rapid oxidation of a material in the exothermic chemical process of combustion, releasing heat, light, and various reaction products. Today, we'll play with fire. But don't worry, it's completely safe. We will explore the application of Newton's second law of motion behind one of the most amazing human-made artifacts, the rocket ship. I'll introduce you to a simple experiment that you can make at home, in which you will learn how Newton's second law comes into play when making a rocket ship. Hopefully by the end, you will learn something. Or not. Our main focus today will be Newton's second law of motion, which pertains to the behavior of objects for which all existent forces are not balanced. When there are unbalanced forces within an object, there is movement, and this movement translates to acceleration. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object, which gave us the equation F net equals NA. As you can see, the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. Therefore, as the force acting upon an object is increased, the acceleration of the object is also increased. But as the mass of an object is increased, the acceleration of the object will decrease, and so inversely. Now that we have reviewed Newton's second law of motion, let's see its applications in real life.
Hi, I'm Ashley Garcia, and have you ever seen a paper towel or a napkin getting burned? Well, it looks something like this.
Well, what you just saw was a combination of Newton's second law in addition to thermodynamics. However, we cannot speak about thermodynamics because that's not part of the course, so we will focus mainly on Newton's second law. For that, we will make a quick little experiment that you can do at home with little to none equipment. However, please make sure that you do this somewhere safe in a well-ventilated area where nothing could catch fire should anything go wrong. For this experiment, you'll need a tea bag and fire. That's it. What you'll do first is empty out the contents of the tea bag. You have to cut it first. And empty everything in a cup. Now you will end up with this fine tube. See? Perfect. Now it should stand by itself. Okay, that works. Okay. Okay. And as it is standing, we will burn the tips. And if this works, it will be pretty great. Okay. And then we wait and wait till it reaches the bottom and it takes off. And as you can see, here come the ashes. The ashes. Now, what was the physics behind this experiment? Let's see. Now, let's get to the physics part of this video. For that, I'll use some free body diagrams to help explain myself better. At first, this is what you have. Two opposite forces acting on the tea bag. We have the force of the table pointing upwards and the weight pointing downwards. Now, as the bag burns, the paper gets lighter and lighter, therefore decreasing its weight, while at the same time, the fire is creating a warm air current that is pointing upwards. Now, this is thermodynamics, by the way. And this warm air current, a more scientific way to say it, is actually convection current. Just so you know. Now, as the tea bag reaches its lightest weight, or when the fire is all the way at the bottom, the weight at this point, the mass, is almost negligible. As you can see, it's basically an ash. Therefore, it is able to be caught into the warm air current that is pointing upwards, making it seem like it's flying. While in reality, there's only one force acting on the tea bag at this point. So it's all physics. And this is exactly what Newton's second law refers to. As the mass of an object was decreased up to a negligible level, the acceleration was highly increased. In this case, acceleration was pointing upwards, so the ashes began to fly upwards. Congratulations! Now you know the physics behind the flying napkin, and you learn a little bit more about Newton's second law and how to explain it to somebody else. Now you can explain this to your friends and family members and look super smart about it. Newton's second law is something that we find in many situations. It can either be rocket ships or fireworks. I encourage you to keep on learning, to keep on discovering, and to keep on doing physics. Goodbye.